Okay, I think we're live. Welcome everyone to the virtual Starry Nights. Joining us on our journey, well, you have our hosts here. My name is Kyle, and joining me...
Indira.
Yes, welcome. And online in the virtual space, we have our moderators, Matthew Simone and Nat Jat. And they'll be helping out with any questions that you might have in the chat. Now, bear in mind, there will be a little bit of a delay on our end, so that's why they're going to help us a whole bunch with helping us. But we hope you enjoy our journey. We're taking you from the inner planets of the solar system, and we'll make our way out into the farthest recesses of the universe. So, join us on our journey. And we're starting off with the king of the planets, Jupiter. And maybe just even to see just on your screen, for those of you that might be new, we have some cameras that are on the side. Those are security cameras that are inside the observatory. Well, one is inside. The other two are outside, just to see what our dear old girl telescope is up to. And we also have our all-sky cam just on the bottom there, just to keep an eye on the sky where the clouds are at. And you might have noticed that there's some clouds passing over our dear friend Jupiter. So that's why we've kind of altered the capture here a little bit. But anyway, do you have a little introduction for yourself, Indira?
Maybe. I'm really excited to do this again. I think this is my second time doing this, which is great. Yeah, so I'm kind of new at the controls here, so I might I might mess up a little bit as I did before. I think I accidentally closed down the Sharp Cap tab, but yeah, so I don't know what introduction do you want me to do?
Oh, good. How'd you get interested in space?
Oh, that's a great question. Yeah, see, before I answer that, can we try to get a new picture of Jupiter?
Oh my gosh. Yeah, let's see here.
Let's see if
the
we can
clouds.
get better.
Okay, hold on.
I don't know what you mean. That's a way better picture than it was before. I'm joking.
I mean, staring at the sun here. We can talk about this in a minute, but
yeah.
Okay, you know what? We're gonna talk. I'm gonna fiddle with this.
Okay. Yeah, so I got into astronomy when I was I think I was in like grade 2 or 3, and I love this story because I recently got a new job working at elementary schools, and I travel around the Lower Mainland doing like science outreach and stuff. And so I tell the kids this story all the time because they're, a lot of the times they're around that age. But when I was in grade 2, during silent reading, I always used to pick the picture books. And the picture books specifically that had, the planets, pictures of the planets that the Voyagers had taken. And so that kind of got me inspired to go into space and learn about how things are made in space, like how planets are made and how the stars are made and stuff. And I find it funny because it's like, I don't know, I feel like sometimes looking at picture books is kind of frowned upon. It's like, you need to read, But looking at picture books, for me, that's kind of what inspired me to go into my field or my profession and study physics and stuff. So, yeah, after that, I think when I was 13, I got a telescope for the first time. I had saved up all my birthday money and Christmas money and stuff. And yeah, I was into space. I wanted to be an astrophysicist. And then when I got into physics here at SFU, I kind of got more into the quantum realm. So
you started with big things,
yeah.
and then you went small.
Tiny,
okay.
Yes.
Okay.
Yes. But now I'm just doing outreach. Yeah, it's a really, really fulfilling job doing outreach and just trying to inspire kids and stuff,
Nice.
But yeah, what about you, Kyle?
Yeah, well, one thing. Can you go to the YouTube tab for a little bit? Okay. Yeah, well, my journey kind of started similarly. It was kind of when I was a wee lad. When I was back at Nova Scotia, I was visiting my cousin's grandparents' place. In Trottier, Nova Scotia, for those that are on the online world who may have been to Halifax, like the only major city for the people who've been to Nova Scotia, the only major city around is Halifax, right? But in a little town called Truro, Nova Scotia, I discovered my passion there. So my mom just out of the blue goes, "Hey, do you want to go to see your cousin's grandfather? I mean, he built his own observatory in his backyard. You want to go there?" And I go, "Yeah, sure." I mean, being a little 6, 7 year old, didn't think much of it. But I go there, it was August, and it was the time of the Perseid meteor shower. And that would have been the first time I had ever seen a meteor shower. So going out there with hardly any lights, there were so many stars I couldn't recognize any of the constellations. There was a meteor every minute or so, which was absolutely mind-blowing. And we saw Jupiter, like you see before you, at least trying to. Truro, Nova Scotia, Jupiter, Saturn. We saw all these different planets, and he gave me, before leaving, these 1986 issues of the astronomy magazine. Like, I think it was 3 or 4 issues. And at the time, it was, of course, the articles were about, what could Neptune and Uranus reveal about the solar system and things like that. And like, looking back on those, I'm like, oh yeah, old news, but new news at the time, I should say. Yeah. Anyway. Okay. This is getting way better, but anyway.
Yeah, so I just wanted to mention that I think we were live stacking before. Is that correct, Kyle?
Yes, we were. Oh my gosh, come on.
So we were live stacking before, but I think it said, like, there was a lot of frames that had been dropped, basically, because it wasn't able to align them, or they weren't, they just weren't good enough. So I think now we're just literally live streaming what the camera is capturing.
Yeah.
Or not capturing. It's going away as I say that.
No, and you can see it. I'm not touching anything. Like, usually we fiddle with the exposure time, so that's how long we open the camera shutter for. Mm-hmm. I'm not touching anything. All the little dimness, and went to black now, but all that dimness is because clouds are going in front of Jupiter, as maybe you might see in the all-sky cam, actually. There is that little dot, so it should be coming out. But if I turn up the exposure here, so now I'm controlling it, you can see the god of the planets.
Yeah.
Return.
Very
cool. Cool. Okay. Nice. So that's exposure time. And also, if I were to just kind of maybe expose it a lot, maybe I turn this up to, I don't know, say 5 seconds. Boink.
Will it not just go...
See. Well, it's going to be super bright because I want something to happen.
Okay. Oh, there we go.
Oh, a couple moons. Oh. Okay, hold on. Okay, wait. So let me do maybe 10 seconds here. Okay, so I'm really cranking up the exposure time here to see some of the legendary Galilean moons. And we see 2 right there on the left and right. Oh, shoot. Should have looked this up before we got online. Which ones are which? I think the moderators might help us out in the chat here. Yeah, maybe NetChat, Abby, I see in the chat, and Matthew maybe can help us out with some of the labeling the moons here. But these are not stars. These are actual moons. And again, the legendary Galilei used these moons to prove, or at least help prove, that the sun was the center of the solar system and not the Earth.
Yes.
I think that was really, really cool. Anyway, okay, sorry, go ahead. I think I may have interrupted you. You were talking about something.
Oh, okay. No. I was just gonna say they're the 4 Galilean moons. They're called that because I think he was the one that tracked them and discovered that they were Jupiter's moons.
Yeah, good old pen and paper too.
Yeah. Oh yeah.
Oh boy. Okay, now it's getting bigger.
It's starting to look like the sun.
Okay.
Yeah.
Okay. How far away is Jupiter? Do you know? I think, if I remember correctly, I think it's something in the billions. No.
I think it's. Oof. No, it's not in the billions. It's almost. Well, almost. I don't know. It's like I think it's like 700
Oh, jeez. Okay, we're getting too close.
million
Okay.
kilometers from the sun.
Sorry.
All good.
Repeat that one more time. I think I...
Like 700, 800 million kilometers from the sun.
Mm-hmm. Oh my god, that's a long way.
Yeah. So, yeah, pretty far away from us. But the moons are actually really cool. One of the moons, what is it? Which moon is it? That is like an ice ball?
Europa.
Europa?
Yeah.
Is that the one that they're trying to study? I think there's like a Juno or Juice or something. Well, Juno is an old one, but Juice is like a newer...
Yeah, no, it's the Juice one, I believe. Juno is the one that's currently orbiting Jupiter, because it's trying to analyze, I think, the weather.
Yeah,
on
Jupiter.
Yeah. Mm-hmm. But,
what about Juice?
Super cool stuff. Oh, yeah, Juice. So, yeah, that was supposed to... And again, maybe you might correct me in the chat, but Juice is all about... actually going to Europa.
Yes. Okay, that's what I was thinking of.
Going to Europa. And checking it out, pretty much. So it's really exciting stuff. Again, it's almost like they're going to take core samples of the ice and actually do a little spectroscopy or spectral analysis on some of the materials of it, which is really, really cool.
Mm-hmm.
So just to kind of see some of that stuff. Clipper. Oh, Matthew got it. Sorry. I'm just looking at the chat now. Europa Clipper. Juice was something else, I think. Anyway. Yes. To analyze core samples. To see what's going on with Europa. And super, super exciting stuff. What else can we say about Jupiter? The different bands.
Yeah, I was going to say the different bands are actually... Well, the reason why it has bands is because there are different... basically, there are like clouds made up of different substances. I believe the browner ones are more sulfuric in composition.
Yeah, like different chemical composition.
Yeah, and so they're not only chemically different a little bit, but they also are at different heights in Jupiter's atmosphere. I'm not sure which one. Maybe someone in the chat can tell me which one is like higher in the atmosphere. I forgot if it's the lighter bands or the lower, the lighter bands or the darker bands.
I think it's usually the lighter bands. I think the equatorial ones are a little deeper, I think. I don't know.
Yeah.
Yeah.
But yeah, and then we have that, that characteristic red dot, the red storm. Kyle, I've been reading up that apparently the storm is like, getting smaller and stuff. Have you been hearing anything about that?
Yes, I have. And it's so disheartening, too, because I grew up with this 300-year-old storm, this great red spot, being this eternal thing, right? And it was always like 2 Earths wide, but it's been getting smaller.
Yeah.
Exactly. Now, due to fluid dynamics, and some of the complicated weather systems and weather extremes on the planet that's causing it to shrink. But right now, I think it's approximately the size of the Earth. So, getting smaller. Yeah. How long does it take to go around the sun? Is it like... 13?
19? I think it's 19 Earth years. Like, it takes like 20... Oh, sorry.
13.
Nope. 13. Half that.
Nice.
Yeah.
13 Earth years. So, I'm going to say my age, shamelessly. I'm 30 years old. I'm a 94 kid. So I would be 2.5... a little less than 2.5 if I was living on Jupiter. However... One day on Jupiter is almost 9 hours, actually, which is really, really crazy.
I think that's like the fastest day in the solar system, is it not?
It is, yeah. In fact, it spins so fast that the entire planet is actually almost squashed, in a sense. Ever so slightly, because it's spinning so fast. It gets very squashed at the equator. So it's almost like an egg sort of shape. but really kind of neat.
Yeah.
Let's see here. Okay, maybe a little bit longer on Jupiter here. If you ever see for those that are on the internet space, if you ever look up the Juno mission, because the Juno mission we talked about earlier with being, it's in an elliptical orbit around Jupiter, and it takes it really, really close to the top of the, quote unquote surface, but I mean top of the atmosphere. But if you were ever to see the orbit of Juno, it goes really, really close, and I'm just so nervous whenever I see that. I'm going, the smart people at NASA are really doing an amazing job. Okay, I'm going to turn down the exposure just a little bit so we can see the fancy bands. Oh my gosh. Oh, there we go. Okay.
That's better.
Turn it up a little bit.
Oh.
Yeah, so unfortunately it's difficult to focus on Jupiter because of that cloud system. Yeah, because of that cloud system going over. We have just, it's a little wispy. Wispy but
clouds.
Doing our best, for sure. Anything else you want to say about Jupiter before we depart to our next object?
Not that I can think of. I'm excited for the other objects that we're going to be
looking at. The other ones?
Yeah.
Yeah, okay. Well, maybe in the meantime, because there was the planetary parade that was kind of happening.
Yeah.
Last couple weeks, actually.
Yeah.
Because of our location right now, the academic quadrangle here is blocking Venus, unfortunately. But let's go a little bit closer to the solar system, and let's see the planet Mars. Let's have a look. Okay. And so we go like this. Go to Mars. Boom, boom. And boom, boom. As we zoom off a little bit closer.
3% dying. It's not charging for some reason. Yeah.
Oh, strange. Okay.
So it's gonna die, is what I'm saying.
Unless
I see. Do you have a charger?
Oh,
oh my goodness!
Yeah. Holy crap! This looks amazing.
Let's try that one.
Yeah, let's try this one. Okay. Let me just adjust a little bit here. Okay, once again, Mars looking pretty good. Looking pretty good. Once again, with the clouds. Oh, jeez, this doesn't look very good. Well, one thing to know. See. Oh my gosh. Oh my god, really? Where'd you go? Come back. Oh.
Is there a cloud?
No. I just.
Oh!
Hopefully it goes back. Oh, yeah, there we go.
Oh.
Okay. A little bit of a glitch with our spaceship, people. Our dome just kind of moved out of the way. It should come back. There we go. Okay, nice.
Okay.
Ooh, very, very bright. Okay. Let me turn down the exposure. Let's see what we can see here. Oh, that's tricky. Okay.
Yeah.
Not the best. However, maybe a couple things before we leave our cosmic neighborhood of the solar system. Yeah. Mars, significantly closer. It's only about 20 million kilometers away, at least from the sun. For us here on Earth, it's about a 10-minute light journey to get there. 10-15 minutes.
Traveling at this,
traveling at the speed of light. Yeah. Like communication. So, any kind of probes that we send there, which it's the only planet in our solar system that's completely inhabited by robots, which is really kind of funny. But if we ever want to send any instructions over there, we have to wait a little bit.
Like yeah, we gotta wait, I guess, the 10 minutes for one way,
Yeah.
and then the 10 minutes for it to
Come back.
for it to come back.
Yeah. So a lot of the probes that we send have to have a little bit of almost like their own AI or computer systems to make decisions for them, essentially. But it's really kind of neat.
Yeah.
Also has some ice caps now because Mars is in. Oh, let me turn down. Oh, you can't really see it here, but because Mars is currently in opposition, which means it's the closest it's the closest it is to Earth in its orbit. We can see it's almost a nice sphere.
We can also would be able to make out the vaguely the ice caps. Maybe is that what you're trying to say?
Vaguely, yeah, exactly. If we kind of had a little bit of a better view, but I mean.
But Kyle, what are the ice caps made of? Are those like regular?
Oh, okay. Whoops.
Are those regular ice caps like we find here on Earth, or are those?
No, those are carbon dioxide. Carbon dioxide ice caps. So, which sublimate when it gets hot. Okay, hot, -5.
Yeah, yeah.
Quote unquote. But they sublimate and turn into a gas instead of a liquid. But there is plenty of evidence that there once was some liquid on its surface. And it could even be a little bit, or I mean, maybe there's some liquid underneath. Maybe.
Yeah, I remember back when I was working at the planetarium, we used to talk about Mars. And one of the pieces of evidence that we found that we used to talk about a lot was the evidence, I believe, of clay on Mars. And so I think clay is only made in the presence of water.
Yes.
And another funny thing, actually, is at my job is that I work with the kids and stuff, and we do an erosion workshop. And I talk to them about erosion, and I ask them how clay is made. And none of them know. But until I say, obviously they're not going to know, but until I say, how many of you play Minecraft, then they know. Then they're like, oh, it's water and like sand or whatever, right?
Yeah.
And I'm like, yeah, exactly. So clay is only found like around the, in the presence of water.
Well, yeah, you just didn't make this up.
Yeah,
right,
this is, no, these are, yeah, exactly. So, pretty cool stuff. And yeah, Mars is, I don't know, after learning about it at the planetarium, I find it really interesting. I think it's like, the sunsets are, I think they're blue, and then the sunrises are red, because it's like mostly a carbon dioxide atmosphere.
Yeah. Well, the sunrises would be blue, I think, as well. Because it's kind of like low on the horizon, right?
But it changes color because of the atmosphere composition.
Okay.
Yeah, so, and if we were to travel to Mars, then I think that would really mess with our like circadian rhythm,
Yeah, really.
And on that note, I don't think we should travel to Mars. It would be a lot. It would be very cold. It would be so cold.
Very cold.
And the atmosphere, the colors, it would mess with our sleep pattern. You know? I know I'd be really grumpy.
Even though a day is, well, I think our day is 23 hours and...
like 54
minutes. Like pretty close to 24. On Mars, it's over 24 hours. Like 24 hours and 15 minutes or something. So we would have to do a little timing adjust.
Yeah.
Something. Anyway.
Oh, yeah. Yeah.
Pretty cool. Yeah. For those book nerds in the digital space, there's a book series called Red Mars, Blue Mars, and Green Mars, all about terraforming Mars and stuff. That's something they have to do in the book, is when they're sleeping for the day. There's an extra hour they put into the night that is supposed to adjust for this time difference. So,
very cool.
Cool book. I would recommend Red Mars for those that want to pick it up. Yeah, so let's now... Okay.
Are we going to exit our...
Yes, we are going to leave our solar system and turn our engines to the distant cosmos. Okay, let us go to a star cluster.
Yay!
In fact, we're going to go pretty far with this. Okay, let me just dial it in. Let me dial it in.
We're locking in.
We're locking in.
Okay.
Okay, we'll go here. Okay, boink. Okay, and then boink.
All right, we are in motion.
We are on the move. Mm-hmm. Yeah, so just looking at the chat right now, imagine Jard is saying, imagine running out of fuel where you can see Mars, but you can't quite reach it.
Oh gosh, that would be. I feel like that's kind of nightmare fuel. Being trapped in space is kind of scary. Like.
Yeah. I don't want that.
Yeah. I mean, what's going on with those astronauts that are trapped in space right now? They've been up there for a long time.
For a little bit, yeah. They should be coming down soon, though. It's because, was it Blue Dragon? Was that what the?
Dragon X. I thought it was.
One of the capsules that was going to bring the crew back down. Unfortunately, it was discovered there was a flaw. And so they took it back down and ran some more, like they did a whole bunch of tests, and they want to make sure that they're safe coming back, essentially. So a little bit of hiccups going on right now, but they will return safely. Absolutely.
That's good. Because that's a bit. I mean, it's
a little scary.
Yeah, it's just a little scary. I mean, it'd be cool to be out in space and looking down on the Earth and stuff, but. Uncertainty about returning home is a little bit scary sometimes.
Yeah, a little bit. But Matthew in the chat wants to get stuck on the ISS.
Oh, all
boy.
right.
Okay, we're exiting hyperspeed. Let me just bring us back.
Oh,
all right, look at this. Okay. Here, ladies and gentlemen, let me just adjust kind of the color balance a little bit. Here we have a piece of the double cluster. It is, maybe you can talk about the double cluster for just a little bit. I gotta make a couple of adjustments. Hold on one second. What can you tell us about the double cluster?
Oh, the double cluster? I mean, like, I just like to look at clusters in general and like star clusters in general just because just by looking at them and the stars within them you can kind of tell a little bit about how old it is. So star clusters like this, I think that this double cluster is, on the grand scheme of things, I don't think it's that old, but it's 14 million years old.
Hold on. I gotta say something. So here at the Trottier Observatory, whenever we say new, old, young, blah blah blah, imagine air quotes.
Yeah,
along these things. So
yeah.
So just bear that in mind.
But yeah, so, and you can kind of, I guess it's easier to see with like reference pictures of like older star clusters. They're typically more densely packed, but this one's a little bit more, I guess, scarce in like the star population, which is pretty cool. And just seeing like the colors of the stars within these clusters will also tell us a little bit about the age of the cluster itself. So I mean, I don't know if it's our camera or not, but I'm not seeing too many like red stars, and like in a star cluster, typically the presence of red stars would mean that it's like a little bit of an older star cluster. Am I correct in saying that, Kyle?
Yes, they are reminiscent of an older cluster. Absolutely. It's because red stars, well, they're red in the sense they don't have a lot of
energy and
fuel to burn, so to speak. Or rather, well, not that they don't have enough, it's just that they burn through their fuel more slowly. They don't have a lot of mass to them, right? So they burn through their fuel very slowly. So if we see red stars in a cluster, that means that there's it's an older cluster.
Yep.
Right? So blue stars, much more massive. therefore hotter,
Mm-hmm.
or actually I should say, more massive, burn through their fuel quicker, and therefore hotter, which means blue. So it's almost like if you imagine your stovetop. If you were to crank that thing to high, okay, and just let it go, and without the elements melting, the stovetop would go from red to orange to yellow to white and then blue. Blue is a very high energy wavelength, so therefore all these hot stars are very blue. But okay, overall, my mind goes all over the place when talking about this stuff. But overall, blue things means very hot.
Mm-hmm.
Yes, that's what I mean to say.
So this star cluster is about like 30 light years away?
Yeah.
Or is it? No.
Approximately 30 light years away.
But the cluster is...
yeah. Oh, yes. Okay.
I don't
So, sorry. Star cluster itself. 7,000 and 7,600 light years away. The reason this is called the double cluster is because there's actually two.
Okay.
If you were to look at this in a... or see a bigger field of view, because here at the observatory we have a much tinier field of view, or more zoomed in, I guess you could say, you would actually see two clusters. The thing is, one of them is actually behind the other. They're almost separated by another distance. So they're separated by almost 1,000 light years, actually, of separation between the two. They're approximately 33 light years in diameter. That's what we're trying to say. But very young, and they're a little bit blue shifted as well. So blue shifting and red shifting, if you've ever, well, the Doppler effect, right, with sound.
Yes.
Yeah.
Yes.
So,
but,
yeah.
Yes. Oh, do you want to go?
Go for it. No.
Well, yeah, so the Doppler effect, my corny joke about the Doppler effect is whether or not you've heard of the Doppler effect before, you've definitely heard the Doppler effect before. If you're walking down the road, you hear a car go by, a siren go, like an ambulance or something, you're hearing like the Doppler effect. And that's, when you hear a car go like, okay.
Do that again? Do that
again? No, absolutely not.
Okay.
And so that change in pitch or frequency is the waves of the sound waves crunching up as they approach you and then kind of relaxing as they go away from you. And the same thing happens with light waves. So when something is approaching you, those light waves crunch up and we see a bit of a blue shift. And then when something is traveling away from you, it's going to, the wavelengths are going to relax a little bit, and they're going to travel away. Like, they're going to relax and kind of redshift a little bit.
Spread out, like, get longer?
Yeah, like,
okay.
less, I guess have, like, a less frequency is what I'm trying to say. So...
Okay.
Yeah. So, that's kind of redshift, blue shift, and I think this is a cluster that is actually blue shifted, which means it's actually traveling towards us.
Yes.
Which is kind of, I feel like that's a little bit uncommon. Typically things in space are traveling away from us.
Yeah, typically really far away things will, like other galaxies and stuff, will travel far away. Things inside our own galaxy, they're just moving all over the place, wherever they want to go. But yeah, more so the blue from the cluster is because of the stars that are in it. Not so much as like going so fast towards us that the light is blue shifted, but I think it's traveling at around 40 kilometers per second.
I mean, that's
when I last clocked
kind of fast, I guess.
That's kind of fast. That's here to Chilliwack.
In a second?
In a second.
Huh. Yeah, that's kind of fast.
It's kind of fast. In space, it's pretty slow.
Yeah, I guess so, eh?
Yeah, anyway. But, double cluster. Very beautiful.
Yes.
Very awesome. And also, seeing it through a telescope, you can see that kind of... it looks 2D, like seeing the clusters right next to each other, but really there's that third dimension where one is behind the other. Yeah.
Let's check.
So.
I'm just gonna check in on this. Why is it?
Uh-oh.
Oh, there we go. We're back. Okay.
Clouds are still looking wispy, we see.
Yeah.
All right. Maybe we should program our next destination.
Yeah. What are we thinking next?
Let's have a look. Okay, we talked about stars. Talked about planets. Talked about stars. How are stars born? Maybe we should see an object where stars are born.
Okay. Yeah.
Let's see.
Maybe like a type of stellar nursery?
Maybe. Let's do it.
Did I spoil it already? Oh,
What?
No.
No.
Okay. Okay,
No.
we are going to move, so...
Buckle your seatbelts.
Yeah, we're traveling. We're going fast. I am speed.
Ka-chow. Nice. Okay, and then I will clear this as we enter hyperspace.
Okay.
Just looking at the chat. Yeah, there were a couple. Yeah, Brian in the chat says there seems to be one tiny red dot in there. Yeah. Bryn, yeah, there's a couple. Yep. And maybe that was in behind the cluster, so maybe it was a little far away. But yeah. So
Okay.
kind of cool. Okay, still in hyperspace as we exit.
So we're slowing down now, yeah.
Slowing down. We gotta add the sound effects. Okay, here's the thing. Uh-oh.
That's not what we want to see. Okay.
Nope. Uh-oh.
Is this in is this a cloud-covered area?
I think this is. Yes.
Okay.
So we are looking south. We are looking south. So for those that are looking at the all sky cam, that's directly below us. And oh yeah, there might be a little bit of clouds there. Okay. Maybe we'll have to revisit this one. Maybe.
Oh, check the dome. Oh.
Interesting.
Wait, check the camera again. No, like the inside camera.
Inside camera?
No, it looks like it's aligned.
Yeah.
Doesn't it? Yeah.
It's all aligned. Oh, interesting.
Yeah.
Okay.
Let's try to. Is that a live stream or can we refresh that? Can we clear that?
Let's see. Maybe let's move to. Let's just move to a star. Let's move to a star. Let's have a look.
Okay.
Realign ourselves. Recalibrate.
Yeah.
Oh, actually. Okay. I will go to a different star. Okay. That's actually close by. Let me just give this a second to acclimate. Okay, let me clear this. Let's just have a look. See where we are.
Kyle, we traveled too fast.
We too fast!
We lost control.
Uh-oh.
Oh, man.
Dang it, Matthew. You didn't pull us out of warp drive fast enough. Okay, whoa. Okay, we're in strange space right now.
We're in sci-fi space.
We're in sci-fi space. Oh, that looks beautiful, though. So this is the star Procyon.
Honestly, I'm really bad with pronouncing these names. So.
Procyon, which is in the constellation Canis Minor. But this is a nice, brilliant blue star. But let's try a red star.
Yeah.
I'm going to go back a little bit. We're going to go back nearby. Okay.
There we go.
As everyone's like, oh, wow, and then we leave. I was like, okay. Take pictures. Take pictures.
Anyways.
Yeah. Okay. Let's see. Okay, we're looking good. We're all aligned. Nice.
All right.
Clear the cache. Okay.
Let's see.
Oh! Whoa! Coming out of hyperspace. Hold on.
Just putting in
Procyon.
Okay. Lower gear. Okay, Procyon. Yeah. You looked at me like Parakion, and I was like, dude, I am no help. I'm sorry, I don't know how to pronounce these names either.
But that's what I love about... Oops. That's what I love about astronomy and space as well, is there's so many different cultures in space as well. Aldebaran and Arcturus are not Arabic.
Yeah.
That's what I mean to say. Arabic, we have lots of Greek and Roman, which we've heard a lot of. And there's other languages in space as well. It's a very unifying science, I like. Okay, here we have arrived at a very large star. This is the star Betelgeuse. Betelgeuse. In fact, it is so bright, the camera's having a hard time focusing or stacking. So I've turned down a lot of the
Oh my goodness.
a lot of the exposure. Okay, that's getting better.
Yeah, I can. I can talk about this one though. I mean, I kind of
sure.
I already yapped a little bit about red stars and stuff. But
Yeah, sure. Take us through.
I mean, this star is really really interesting because scientists think that it's approaching kind of its end of life stages.
Ooh. It could have already.
It could have already. Yeah, it's actually yeah. How far is it? Like, how many light years is it away?
It's about 400 light years away.
Okay.
And it is about as big. It's a red giant star, and it's about as big as Jupiter's orbit is big around the sun.
Oh.
So if you were to place Betelgeuse where the sun is right now, it would extend out to Jupiter's orbit.
That reminds me, when we say, because we talk, like, I use Betelgeuse as a analog or analogy for, like, what's going to happen to our sun, because I think our sun is eventually going to swell up into a red giant as well.
Yes. Yes.
And I'm a little bit shaky on the details, but I'm pretty sure it's also going to expand out to a planet's orbit.
Yeah.
Do you remember what orbit?
I think it's also...
Is it Mars,
it's going
or?
to just be Earth or Mars, right?
Yeah.
Because there's been some various predictions on how far it would be. It's definitely going to consume Mercury and Venus.
Well, yeah.
Rest in peace. It might make it out to... So we're talking about the sun right now, our home star. But it could swell up to Earth's orbit. It's not going to be a very big red giant.
Yeah.
Even though that's conflicting words right there, but
a little red giant.
Yeah.
Yeah. But yeah, so I use it because it's kind of like, I think that we're seeing that phase that it's
the
that
death
red giant
throes.
phase. Yeah, yeah. But what's different, and I don't know if this is gonna happen to our sun. I don't think it's gonna happen to our sun. What's different about like Betelgeuse is that scientists kind of want to see it like die.
What? No, we don't.
They want to see what happens, and I think this also sets it apart from the sun, because I don't think the sun, like, if Betelgeuse like dies, what kind of death are we expecting it to undergo?
Well, it'll be a supernova, but it's very, very far away, so we're not really going to be like. There's going to be no disasters. Earth will be unaffected. But it will be as bright as the full moon.
Yeah, so that's why they want to see it die.
Yes,
because they want to see that.
It's going to be a wicked bright object once it does explode.
But I don't think our sun has the mass for it to undergo like that. So it's just going to, like, basically shed off its outer layers, right? And then become...
planetary nebula.
Yes. Yes. So but eventually all that will remain will be like some sort of like dwarf star in the sense. Yeah.
Exactly. So it'll be a white
endings.
dwarf.
Yeah. So different endings. But yeah, it's cool to see a red giant in action, and it'd be a lot cooler to see a red giant not in action, maybe, exploded.
Not in action. Okay.
Oh, come on. Are you saying you wouldn't be excited to see that too?
No, I would be excited.
I remember, I think, what was it, the Pinwheel Galaxy? There was this a supernova that went off in, I think it was the Pinwheel Galaxy.
Yeah.
The arms.
Yeah.
And seeing the light from a supernova was just so, I don't know, it was crazy to think about. And I think I think it was Matthew who's in the chat who was saying he wanted to look at it and he was like, I want photons, like light from a supernova to hit my retina. And I thought that was such a cool way of putting it, because it's like those photons have traveled like all the way through, so far away, and then they hit our, eyes. That's pretty cool, right?
Yeah.
Live.
Live.
But yeah, so I think it'd be really cool to see that. When scientists say that it's going to happen soon, that is once again like on the cosmic scale, like a relative scale. So it's kind of like how that double cluster that we were looking at earlier is considered young, but it's like 14 million years old.
Yeah.
Soon can be like, it could be tomorrow, it could be like millions of years from now or something. I'm not quite sure on the exact numbers, but yeah. Soon on the cosmic scale.
Okay. So we're trying to return to the Orion Nebula, which is just below the belt. I'm just having some difficulties with trying to find the darn thing.
Oh, the nebula.
Oh
yeah.
Oh. Sorry, I get really excited with this kind of stuff.
We were going to talk about how stars are born.
Yes, how stars are born. Well, okay, we jumped ahead. We talked about death first.
Yes.
But we should talk about birth.
Well, with death comes more birth, right?
Yeah, exactly.
Yeah.
With death comes new life. What we have here is the Orion Nebula. Not as prominent as it could be because of the clouds, unfortunately.
We're trying.
Oh my gosh. But the 4 stars that you see in the center of the frame there, that is the trapezium. I'm just going to zoom in a little bit. Oops. Too much zoom. There we go. The trapezium. These 4 stars are giant stars. I think they're blue as well. And they output so much energy that it illuminates the nebula.
Yeah. So this is is this not a reflection nebula?
Yeah,
then?
This is reflection and a little bit of emission in there as well. Some of the gas also emits its own light.
Yeah. Because
of the radiation that's hitting.
Oh yeah. Okay. Yeah. So there are different kinds of nebulae. There's there's the emission, and then there's reflection. And
absorption, I guess, technically. Or rather nebula that they're called dark nebula.
Yeah.
But they almost... this is interesting. This is a nebula, dark nebula, which don't have any stars in it. So it's almost they block the light of the stars behind them. So from our perspective, it looks like it's dark.
Okay.
Which is kind of cool. The Horsehead Nebula is one of them. Yeah.
Yeah.
Like the
so
image of the horse.
couldn't different parts of a nebula be like reflection, but then also kind of like absorption as well? Like if the nebula is big enough, if there's not like a star nearby, kind of thing.
Good bits of that.
Yeah, pretty cool. Because I know that if we could see the clouds a little bit more clearly, then it would be. Sorry, just looking at
We're looking at the all sky cam, and literally the clouds are right where we're looking.
Yeah. I meant the Okay, so if we were to see the nebula a little bit more clearly, then we could see that some of those stars, they are kind of like, I guess, ionizing the gas, causing it to kind of light up. And it gives off that beautiful color that we see in the nebula that we can't see.
Just to interject, I just see a question from Pride in the chat. Just to, the overall haziness of the image is due to the clouds here on Earth. But there's these little structures that you can see. There's one right here. There's almost like a circle around the trapezium there. Though that is part of the nebula. But the overall haziness is, unfortunately, the clouds. So,
yeah.
Kind of sucks. Anyway. Okay, sorry. Yeah. Keep going.
Oh, but there's also, I'm not gonna leave the mouse on the image. I'm gonna take it over here. There's also another kind of nebula called a planetary nebula. I don't know if we had that on the menu for tonight. Kyle, did we have that on the menu for tonight?
On the menu, I like that. Unfortunately, not.
All right,
not tonight.
Then I'm gonna talk about it because I have beef with this, and anyone that knows me knows that I have beef with the name planetary nebula. Okay.
Oh my god.
Because when I first heard it, I was like, oh, okay. And to be fair, I feel like I'm a very gullible person. I just kind of take things at face value. So when I heard planetary nebula, I was like, oh, planets must be born there. Which feels so silly now in hindsight. Anyways. But those are... That's a type of nebula that happens when a star dies and it's not quite big enough to undergo supernova, so it doesn't, like implode on itself. Rather, what happens is it kind of sheds off the outer layers of the plasma gas that the star is composed of, and it does that until a little dwarf star is left behind. And so the result of this is a really circular or like spherical looking nebula or cloud of, nebula. And so the reason why it was called it is called planetary nebula is because the first person to observe one of these, which I want to say might have been William Herschel. I'm not 100% sure, but he observed a lot of things.
He did. Yeah.
So when the first person to observe it saw it, they actually thought that it was a planet because of how circular it was. And so...
Messier as well. Charles Messier.
Yeah.
Mm-hmm.
But, so they thought it was a planet, and then so from there the name kind of stuck, so we call it a planetary nebula. We call it that just because the first person to observe one of these thought that it was a planet, just because of how circular it is. But, so I can't think of a better name, to be honest, though. So
true.
True. But younger Indy felt very misled when she learned this information.
Oh my gosh, yeah. But cool nonetheless.
Yeah.
But yeah, so Orion Nebula. I'm gonna try one more time. I'm gonna clear this image here, and I'm gonna see if maybe the clouds quote unquote move. Oh,
there we go.
Are we lucky?
Oh my gosh. Oh my gosh!
Look at this. Okay, look at... Whoa. Okay.
Kyle.
Good.
Calm down.
Okay, hold on. Let me brighten it a little bit. Look at this. Look at that.
Oh my gosh. There's the clouds we were talking
about.
There we
okay.
can see like the reflection and some of the emission. We can see. There's also what I find cool about this. I'm
actually gonna clear this up a little bit more because there's that little white streak going across. So either a plane or a satellite went over. Anyway.
Okay.
Okay. Hopefully I don't jinx it. Sorry.
Yeah.
Go,
what
go,
if
go.
a cloud goes over now?
Oh, it's fine. It's fine.
We're hedging our bets here.
Yeah.
No, I feel like I have to reference the picture, but in the Orion Nebula, you can see actually like parts, like clouds that aren't lit up at all, and so that's kind of why I was asking about how you can have kind of two, because like if you look at these patches here, right, they're really dark. I'm assuming they're dark because there's no stars around to either like. For the clouds to reflect their light or become ionized by
it's like
their
it's
energy.
In front of it, right?
Yeah, exactly. So I think that's what I find. This nebula is pretty cool. I think it's a great example of
pretty cool.
It's cool, I guess. I mean, it's
it's That's one way to put it.
Yeah.
Let me see if I can adjust this just a little bit more. I'm not going to risk moving this again, or clearing the image cache. One more time. There we go. Alright, cool. Yeah, okay, so I don't think we didn't mention how far away it is. This is about 1,300 light years away. And it is the brightest naked eye nebula.
Yes.
That's a title. But yeah, if you go to a dark place and you look at Orion, And right below the belt, there's like this wispiness right below the belt. That's the nebula. So you can see it with your naked eye. It's really, really cool.
I think this was one of the first nebulae that I actually saw through my own telescope.
Oh my gosh!
And yeah, that's when I learned actually. I was 13. I felt very spoiled by NASA's pictures and stuff. So I expected when I looked through the telescope to see something like what we're looking at now.
Mm-hmm.
And so when I saw the clouds, I didn't quite understand. I was thinking that there was like maybe a cloud in the sky or something.
Mm-hmm.
And it's kind of interesting. I feel like a lot of people that come here and have the similar experience that I had, where you look at it with your own eyes through the eyepiece of the telescope, and it's like you're not seeing those like brilliant, gorgeous NASA photos and stuff.
Mm-hmm.
But that's just because with cameras we have a longer exposure, so we can collect more of the light, and with our eyes, it just kind of takes those photons, those bits of light, and just immediately sends it to our brain for processing. So
exactly.
We're not able to kind of, have a long exposure.
Mm-hmm.
But yeah, it's kind of a funny experience looking back on when you're like, getting into astronomy. You're like, oh, I can't wait to see this, like the Ring Nebula, for example.
Yeah.
Like actually the Ring Nebula shows up pretty good with color.
It is pretty good. Yeah.
But like, you're trying to look at a nebula and you want to see all those purples and the pinks and like all those gorgeous colors, the reds, and then you just see a cloud. And it's like, oh. Yeah.
Yeah.
But
no,
yeah.
I agree.
No, the Ring Nebula I think is actually my favorite nebula to look at, just because of the gorgeous color that comes through. Like even if you're looking at it through the eyepiece, it's just it's like brilliant. It's incredible.
Yeah.
But yeah.
So awesome. Okay,
Yeah.
Just taking a look at the chat, see if there's any big questions. So, this is birthplace of stars, essentially. So, I know. That's okay. Space is cool. Birthplace of stars contains tens of millions, or rather, it's tens of millions of years old, but it contains hundreds of new stars inside of it that are being born. And it's about 24 light years in diameter, this nebula. Really kind of cool.
Yeah, I think.
Yep. 700 stars.
Yeah, so I think, and what we were saying earlier about with death comes more life, is that like this is this is
the start.
So this is like the start of where stars are born. They kind of just like when a star is born, I think that's a movie title, whatever.
Yeah. A star is born.
It begins to kind of collect all that gas and that dust and build basically itself under its own gravity kind of thing, right?
Yeah.
Like that's how stars are made. And so when there is a supernova or let's say it rather a nova, like clouds from a dead star, let's say,
right.
Those can be birthplaces for like do you know what I mean?
New stars?
Yes.
Proto-stars?
Yes.
Okay, yeah.
Do you know what I mean?
Yeah. Yeah. So, yeah.
I lost my train of thought there.
No, I know.
I'm still recovering. By the way, I just want to go on record to say I'm still recovering from some illness.
A little bit of illness.
Yeah, working with children, it's you learn all the latest illnesses and stuff, and then you get them.
But hey, they're brilliant sponges for information and energy.
The children?
Yeah.
Oh yeah.
Yeah.
No,
School children,
like
they're awesome.
Like I said, it's a very fulfilling job. I actually really enjoy, like, I go into work, I'm really excited kind of thing. Like, oh, I'm going to teach the kids about Newton today. Like,
yeah.
But unfortunately, so cool. The caveat with that is that you learn that there's, all the latest viruses, all the latest flus. And so I've caught 2 out of, I don't know how many.
2 out of a lot.
2 out of a lot, yeah. I've been getting, like, whiplash, like, 3 weeks separate. 3 weeks ago I got sick, and then now I'm sick again, and not having the greatest time, but I think it's worth it. I don't know. It's really fun being an educator and stuff,
I love it. Love it too. All right.
Yeah, that to say, my I'm gonna, my head's kind of foggy is what I'm trying to say.
You're good.
Sorry.
You're good. Plus, this is a really awesome photo, so I can see that, we could get distracted, right?
Yeah, exactly.
With its beauty.
Yeah.
Anyway. Okay, so, Orion Nebula, birthplace of stars. So let's move on a little farther out. Let's see. Now, here at the Trottier Observatory, we like to be a little ambitious. So we're going to try and find a star cluster that is incredibly far away. Really cool. As we hit warp speed.
Okay, let's go. We're taking off.
We are. Okay, I'm going to clear this one more time. And we're going to see.
Which part of the sky is this? Can we just take a look?
So, we are kind of...
Southeast?
Uh-oh. Yeah, Orion was south.
Yeah, we're southeast.
So we're about southeast right now. Yeah.
Are the clouds up in that area?
Let's have a check. Yeah, a little bit. But let's see what we can see. This is a star cluster. So let me just do a little bit of adjusting. Oopsies. Get us back. There we go.
Nice.
Okay, and then we go like this, and then we go like this. And we go like this. And we go like that. Whoa! Okay.
Okay.
So this is kind of a first for us. Oh, well, okay. Unfortunately, the clouds are actually not cooperating.
Dang.
Oopsies. So we're trying to observe a star cluster. In fact, this is one of the farthest star clusters we have yet seen here at the observatory. This is called NGC 2419. Located around 300,000 light years away.
Wow.
Also called the Intergalactic Wanderer.
I think
so,
I prefer that name. That's a cool name.
That is a really cool name. Now, I have a suspicion. There's a little hazy spot right here.
Yeah.
I wonder if because this cluster is so far away, we can't pick out the individual stars.
Yeah, so it just looks kind of like a cloud, right?
Yeah, kind of a little bit of a cloud. Now, I mean, it doesn't help there are actual clouds in the way.
Yeah.
But try and be ambitious.
Yeah. I mean,
try as we might.
Yeah.
But this is kind of a first for us. Now, with the Intergalactic Wanderer, it's about 260 light years across, and its orbit takes it farther away from our galaxy than the Magellanic Clouds. So it's almost like this star cluster, well, it is, orbiting our galaxy.
Wow.
Holy smokes. That's really cool.
That's incredible.
And, okay, this is a long time. It takes 3 billion years to orbit the Milky Way. That is objectively long. So, yeah. But this one's a little tricky to see. I don't know. Should we let it...
also, did you mention how old it is, too?
No, it's really old.
It's really, really old.
It's about 12 billion, with a B, billion years old.
Yeah.
Which is nearly as old, or rather as old, as our Milky Way galaxy, our home. Oh, yeah, they're not stacking.
They're not stacking?
Okay, dang. Okay.
That's okay.
Well, we try and be ambitious.
Yeah.
Here at the observatory. Sometimes we fail, but sometimes we succeed. Sometimes we succeed, but that's okay.
It's not always about succeeding, though, Kyle. You know, you got to try trial and error, right?
That is true.
That is the way. You know.
That is true. Okay. Well, we got another cluster in our back pocket here. Okay. Let's have a look.
Oh, is this the one? Yeah. Okay. Wait. I put this one on the list.
Yes.
It is the last day of February, and so I wanted to have a Valentine themed object, at least one, as we say goodbye to February, 'cause I think it's the last day. Tomorrow's March 1st. Where did the time go?
Oh,
Anyways.
yeah, really. Oh, God.
So we're headed into warp drive towards the heart-shaped cluster. Is that correct?
The heart-shaped cluster.
Yeah.
M50. Oh boy. Coming out of warp space here.
Yeah, I gotta slow down a little bit. Yeah.
Yeah. All right. Okay. Takes a few seconds.
But yeah. I don't think when was the last time we ran Starry Nights? Did we run it all on?
Not
February?
last week. Oh, we ran a couple times in February.
Okay.
Definitely not last week. I think we were clouded out, but definitely a couple weeks before. Let me just do a little adjusting.
Oh no, we weren't running for Valentine's Day either. I remember because I was like waiting for that email, press and refresh. Like,
oh yeah.
Are we gonna do it? Are we gonna do it?
We're gonna do it.
But yeah, so I feel like we didn't get to roll out with our Valentine's themed star
list.
Yeah, exactly. So this is kind of just a little taste of it. But yeah, so we're trying to hone in here on the heart-shaped cluster. That's better. Yeah,
cool.
Looks good.
What you may notice, remember back to when we were at the double cluster, there's more red stars, it kind of looks like here, than blue stars. Or at least there's rather more prominent red stars.
Yeah.
Yeah.
That tells us it's probably a little bit older then, isn't it?
A little bit older, yeah. This one...
It's actually a lot older.
It is a lot older, actually.
Because the double cluster was 14 million years old, but this one is
10 times older.
as old. So it's
140
140 million years old. So yeah, and you could see that with the presence of red stars, and I would say the density is not too dense. It's not
no
unless we're looking like at a part of it. Are we looking at the entire cluster right now?
I think we're only looking at a part of it, actually. Yeah, I think it continues more to the right and below as well. So it's, excuse me, a little bit bigger. I mean, 18 light years across. Pretty good.
Pretty big.
Located in the constellation Monoceros. That's where we are right now.
Is that how you say that?
Yes. Yes.
I'm just messing with you.
Monoceros.
Monoceros.
But yes, heart-shaped cluster. Again, another example of a different, quote-unquote, slightly different, star cluster. Still technically an open cluster. It's not as dense as something like the Hercules star cluster, which is billions of years old and hyper dense of stuff, right? So definitely younger, more open. This one probably contains, maybe maybe not even 1,000, maybe few hundred stars. When something like the Hercules cluster contains something like 500,000 stars, which is crazy incredible. So, yeah.
How far away is this one?
Oh, just under 3,000 light years away. It's about 140 million years old.
Yes.
That's its age.
Yes.
But it's about 2,800 or just under 3,000 light years away. Yeah.
Okay.
Not too bad. Not too bad.
Not too shabby.
All right. Okay.
Are we moving on?
We're going to move on. We're going to move on.
Okay.
We're going to be, again, ambitious. We are going to leave our galaxy and potentially look at another. Let's have a look. Let's have a look. We will boldly go. We will boldly go where we haven't before.
Where no Trottier Observatory staffer has gone before.
Has gone before.
Jokes. Okay.
All right. As we jump.
Okay. Sorry. Clouds. You know what? For the clouds that we're seeing and like the wispy clouds, I think we're doing pretty good tonight. Like we've seen some pretty incredible things. I'm really happy that we got the opportunity to do this today.
it's been working out pretty nice. I mean, yeah, with some of these clouds, like at least, well, okay. Firstly, it's awesome that it's wintertime because we can see a lot more stuff because it's darker, right? But it's just some of the like deeper sky objects can be a little trickier to see. Like something like planets, like Mercury, or rather, sorry, Jupiter, Saturn, Mars, places like that. Usually they're pretty good to see, even when there's a few clouds in the night sky.
Oh, look at that!
But for deep sky objects, sometimes sometimes it can be all right.
Okay. So is this?
Okay, hold on. Let me just bring that. Oh, and out from the darkness we get light.
So what do we? Did you already say it? What are we looking at here?
No. This is. Oh, let me just kind of adjust this a little bit. As more pictures come in, I'll kind of adjust the image quality as we continue. Here we have a galaxy. This is the Cigar Galaxy.
Very cool.
Very, very cool. It is on the order of, I think, 15 or 20 million light years away. Million light years away. 12 million light years away. Holy smokes. Now, again, with the clouds in the way, this is actually looking all right. But you can see, maybe if I adjust the levels a little bit.
Why don't you click the auto button? See what the auto button does.
Well, it lines up the hubs here. So
I see.
This is what we got. But okay, so the galaxy's right here. There's a little bit of a black, almost like a missing spot, or line, I guess, in the galaxy. That's due to like kind of another part of the galaxy blocking the light. It's almost like it's in the outskirts of the galaxy, blocking some of the starlight coming in. So this is really quite cool. And now, it's shaped like this because we're seeing it edge on.
I was gonna say.
Yeah.
Yeah. So what kind of like? If I guess we don't really know. Like, what would it look like from?
Not so much. I think astronomers have discovered it is a spiral galaxy of sorts.
Mm-hmm.
It's just with it being edge on, we don't know its exact structure.
Yeah.
I'll say that. It is a spiral.
I will say that's why I really enjoy looking at like the Bode's galaxy, for example.
Oh, yes.
Because it's that perfect angle where it's like it's not just like, you know, a flat object, but it kind of looks 3D basically because it's kind of like tilted a little bit.
Yeah.
And yeah, that's what, I don't know, if you know me, you know, I really like it when like the planets look 3D as well. That's why I like looking at Saturn and stuff, because it's like you see the rings and like, I don't know, maybe I'm just you know, a kid at heart, but I really like it when things pop, you know what I mean? The pictures, they pop.
The thing is, aren't all scientists kids at heart? Because we essentially like poking things. Right?
Yeah.
And seeing what happens.
Yeah.
Or looking at things and seeing how awesome they are. So, yeah.
Yeah, I mean, I tell the kiddos, like, oh, a scientist is just someone that asks questions and then, you know, like, tries to find answers to those questions and stuff. And if you have that mindset, then, you know, that's the mindset of a scientist, right?
Yeah,
so,
exactly. So, more on Cigar. Contains about 30 billion stars, approximately. And it's about 18,000 or 19,000 light years across. Compare that to our own, which is nearly 100,000 light years across. Our very own Milky Way is bigger than Cigar. But really, really cool. This is an incredible galaxy. And it's nearby Bode's.
Oh, yeah.
M81. This is M82 for those Messier catalog people out there. But really, really cool to see. And you can see all this structure is from the galaxy. Like, nothing else is in front of it. Like, in terms of, like, other gases or whatever. This is in the galaxy. This is outside of our own galaxy. Really, really cool stuff. And And that's the thing
Ooh, yeah. There we
with... Yeah, this is getting
This
a little
is a great
better.
image,
This
yeah.
is cool. That was the thing when Charles Messier was looking at these objects way back when, because he thought he saw comets. I mean, he was trying to find comets to begin with. But he found all these objects and he wrote them all down. And it wasn't until later astronomers looked back at these things with better technology, better telescopes, that said, oh, no, these things are actually much farther away. And it's really, really interesting. And it wasn't until, like, I think it was the late 1700s that like these galaxies, nebula, things like that, were thought. Well, okay. Firstly, astronomers didn't know they were galaxies to begin with, but they thought that everything was inside the Milky Way. Like our Milky Way was the entire universe.
Yeah.
Right. And then came better technology and better observations, which means we had to refine our conclusions, right?
Yeah.
And these things are in fact outside. It's a pretty wide universe out there.
Yeah, for sure.
Pretty darn cool. Let me just check the chat. Everything's looking good. Hope you all are enjoying the session so far. What else?
Were we not gonna try to look at Maya, or is that too risky?
Well, hey, we like being ambitious.
Okay.
We like being ambitious here. We just want to tease you in to the wider universe out there. Let me zoom in a little bit and see. Yeah, kind of.
I think like.
Kind of looking okay.
Kind of like
Whoops.
Yeah, when you zoom in on this thing, it's kind of like zooming in like on a picture on your phone, right? Where it's like, where you're kind of foregoing some of the quality to see it closer, but it's still pretty cool to see it from a closer point of view. It is still cool. The change of colors, like you see like that, it's kind of like a deep pinky red in the center there.
Yeah. And that could be some of the older stars we were talking about earlier.
Oh,
right?
yeah.
Mm-hmm.
Oh, yeah.
Some of these, which is kind of nice. Okay. So, cigar, really awesome. Maybe we'll try and find some more galaxies in just a bit. I see there's kind of
clearing.
Yes. There's a dip in the clouds.
Wait. So where is the Maya?
Let's have a look.
Like, because if it's blocked by the clouds, we should probably check for that.
Let's see. So kind of
southwest?
South. Yeah, clouds are kind of over here. Let's have a look.
Okay, we'll try. Ambitious. We are trying to be ambitious today.
And I'm not going to clear the image because, I mean, more time looking at a galaxy, right?
Oh, absolutely.
Right? Mm-hmm.
Yeah. Well.
Pretty neat. I don't know, galaxies are really, really awesome to me because they're almost like they're cities in space.
Yeah.
Yeah. Kind of more densely populated in the middle.
Yeah, that immediately makes me think, like, where's the suburbs then? Like.
Well, the outer arms, right?
The outer arms.
So, yeah.
Okay, yeah.
Mm-hmm. Kind of the suburbs.
Yeah.
Yeah.
Interesting analogy. I guess, yeah, because then the spaces in between the galaxies, that would be like just the rural.
Yeah, the wide open roads.
Yeah.
Between cities.
Wild West. Yeah. Okay, that's pretty cool. I like that analogy.
Which is pretty cool.
Yeah. So I think we're trying to.
Okay. So
Yes.
Trying to find
the Maya.
The Maya
Nebula. Yeah.
Okay. Once again.
So this is around. I believe this is in the Pleiades cluster, or around it at least. Go a little bit. Yeah.
Okay, this is where we might have to make a fine adjustment. Because essentially we're looking at the Pleiades star cluster. Because the Maya Nebula, if you've ever seen some really high resolution photos of the Pleiades, there's almost like a haze around them.
Yeah, yeah.
Right? So let me just have a look. I just made a slight adjustment. Let's see. Yeah, once again, we have the exposure set to 20 seconds. Very low. Oh, okay, hold on.
I kind of like those pictures. They're kind of cool. They're like
They're kind of cool.
speed and stuff, you know.
I am
Looks like
speed.
Yeah, I don't know if we've been able to observe the Maya Nebula. I think that we've tried before, and it has proved to be a little bit difficult.
Very difficult.
Yeah.
I haven't seen it before.
Yeah, so this is like a first for us.
Okay.
Or at least for me and Kyle, I guess. I don't know if we've observed it here at the observatory before.
Okay, I'm just going to really ramp this up. Maybe a little bit on the side there of the star.
Mm-hmm.
I think right there. Yeah, because the nebulosity should be just around the star.
Yeah.
Kind of like the haze, like right here. But again, with the cloudiness, it's a little difficult to tell.
Yeah.
Yeah, I think we're kind of deep in... Oh, shoot. I think we're kind of deep in the clouds here. Yeah, so this is west, slightly southwest.
I think that's where the clouds
Yeah,
are.
I think...
Yeah.
Oh, shoot. Okay.
Dang it.
Grumble, grumble. Grumble, grumble, grumble.
Yeah, this is, by the way, this is why we like to put our really nice expensive telescopes into space, because in space you don't have to worry about clouds, right?
Mm-hmm.
Or rain, like we do in Vancouver.
Yeah, exactly. The lovely place we call home.
Yes.
Which it is lovely. It is lovely.
Oh, yeah.
Yeah, well, regardless, we are in the Pleiades star cluster. So it is the closest star cluster to Earth. You can see it with the naked eye, actually. It's one of those things where well, people used to test their vision with the Pleiades star cluster. Like, it was back in medieval times, archers, when you were being trained to be an archer, you would look at the Pleiades and you were tested. How many stars can you see? If you saw 7, which is why the other name for the Pleiades, the Seven Sisters.
Yeah.
Then you had 20/20 vision, you could be an archer. But if you couldn't, then you didn't have a good vision.
But what if, like, could you not just like cheat and like go to your archer friends like, yo, I heard the answer is 7. Just say 7.
Yeah, and then you're either killed or or you miss your targets every time.
Yeah, that's true.
Right?
That's true. Yeah.
So, yeah. Okay. 444 light years away, approximately. It's close enough we can actually get a pretty decent read on how far away it is. But about 400 light years away, magnitude 1.6, so you can see it with your naked eye as well.
Do you know what the threshold is for naked eye viewing in terms of magnitude?
Jeez. Well, everyone's kind of different, though.
Right. I think...
That's a great question.
Yeah, I think that we have like a rule of thumb here in the observatory.
Is that magnitude 3 or 4?
How bright do they need to be? Brighter than the 6th magnitude.
Oh, okay.
So that would be... No, it's brighter than the 6th magnitude. That would mean that it's either a 6 or below. Because the lower you go, the brighter the object.
Yeah, exactly.
So it'd be like 6, 5, 4, 3, 2, 1, 0,
Yep.
and then all the way back down. Yeah.
Magnitude scale. Magnitude scale is, the smaller you go, the brighter it is.
Yeah.
To give an example, our sun is a magnitude... magnitude negative 23.
Sorry?
For the sun. Magnitude of negative 23. That's the magnitude of our sun. So, pretty bright.
I think that's bright, yeah.
Yeah, pretty bright. Mm-hmm.
Yeah. But that's why that's from our that's not absolute magnitude, correct?
One more time.
That's not absolute magnitude.
No, that's apparent. Yeah.
Yeah.
Apparent
So that's
magnitude.
okay. So that's what I was gonna say is that like the farther you get, obviously the dimmer the sun is gonna get, right? And so that's why we have like an absolute magnitude scale as well, right? So
yeah, exactly.
It's kind of like so that you can kind of like scale the stars on their brightness independent of their distance from us. Basically.
Yeah, and I think the absolute magnitude scale is, excuse me, you have to be a certain light years away.
Mm-hmm.
I think it was 4 from a certain celestial body. 10 parsecs. Yes. Okay, so 10 parsecs. Yeah, because this is a trigonometry thing.
Yes.
10 parsecs. So that's about 30 light years away. So my correction. For an absolute magnitude. So for our sun, I think our sun's absolute magnitude is like a 4 or a 5. Like, we're a pretty dim star.
Dim. Yeah.
We're a pretty dim
we
star.
have a humble star. We have a humble little average main sequence, just regular Joe Schmo star, right?
Yeah. We're a pretty regular star.
Yeah.
We have a pretty regular star.
I like that, though. That's stable.
That's true. That's true.
Good.
Oh my gosh. Okay, it's getting cold and it's getting lonely out here.
Yeah.
So we're going to take it... We're going to come back to the solar system. It's a little scary out here, too.
Yeah.
So we're going to come back.
Oh, it's right there. Okay.
We're going to come back. So we're going to move on from the Pleiades and the Maya cluster. Or, sorry, Maya Nebula. Pleiades cluster. Jeez. And we're going to come back. Come back to the safety of our solar system.
Yeah.
We're going to try and view the planet Uranus.
Yeah. I feel like this one we don't really get to view as often, I guess.
Not as often, no.
It's not that bright. It's pretty far away. It's not that bright.
No, exactly.
But let's see what we can do.
We'll see what we can see.
I think all evening we've been defying the odds by getting some spectacular views.
I know,
and
right?
hopefully that can continue. We'll see.
Oh!
There we go. Okay, wait.
There it is.
I'm gonna try to.
Okay, you're on the controls.
I'm on the controls. I want to see. Okay. Oh.
Yeah. So we want to go
this way. Okay. Yeah. Okay.
That's not bad.
That's pretty good.
See,
Did we turn the exposure down? It's
yes.
a bit bright.
Yes.
Yeah.
Because I want to see the blue color.
Yeah. Yes. Exactly. And then we can talk about chemicals. Okay.
More chemicals.
Yeah. Oh. Having a hard time aligning.
Well, that might be due to the clouds too, so maybe clear it,
okay.
And then let's see.
Okay. Or at least maybe we could talk about atmospheric composition then, and whatnot. Okay, it's still a bit bright. I'm gonna turn the exposure down a little bit. Yeah, I'm gonna clear it again. Hopefully.
Because it is blue.
It is blue.
Yeah.
I'm gonna turn it. Okay, I'm just gonna try one more time. Is that okay?
Oh my gosh! Sure. Yeah.
All right, let's try this again.
That's crazy.
This is pretty nice. Okay.
This is pretty
I feel like,
good.
Did that not clear?
Oh, wait. I got one thing last thing, Troy.
Okay.
Okay, so we go like this. And we're gonna do it live.
Okay, let's do it live.
We're gonna do it live.
That's a good yeah.
Oh, and then we dim it a little bit. We're gonna dim it more. Okay, greenish blue.
Yep.
That's kind of what we're going for Uranus. Okay, let me zoom in, actually.
Yeah.
Let me zoom in. Okay. Oh, a little bit there. Okay, and it's because of the clouds that it's kind of
dancing?
wibbly wobbly. So, yeah, we're going to turn it up a little bit.
To 4 seconds?
Yeah. Just to kind of be cool about it. Let's kind of see. Oh my gosh, and we're approaching the end.
Oh my gosh, it's almost the end. I didn't
end.
notice. Okay. Well, why is Uranus green?
Geen? Geen. Okay.
Oh my gosh. No, I gotta lay off the
yes.
the lingo. No, why? Okay, but Kyle, why is it like it's got that
green
blue color to it? Why is that?
So it's got the stinky chemical in it.
Right.
It's got methane in it.
Methane.
Some ammonia in there, hydrogen, helium, all sorts of that stuff. But again, it's all due to the chemical compositions.
Mm-hmm.
Is essentially what's going on.
So, Uranus is stinky?
Yeah, Uranus and Neptune
Oh, they're
are
both
kind of
stinky?
stinky. They're both a little stinky.
Stinky planets.
Yeah.
Oh, okay.
Both a little stinky. But I've turned up the exposure time yet again because let's leave ourselves on a nice starry background. Because that's always really cool. That's always really nice. Let me just turn it on. Just like that. Okay.
There we go.
Ah, yes.
Oh,
yeah, so a lot of the stinkiness is from the ammonia. Sorry, my apologies. Yeah. Dobby coming in. Yeah, so, again, lots of chemicals that makes it a different color. And the thing with Uranus... Okay, this is the last thing we'll say, too.
Yeah, we gotta wrap this up.
Yeah, we gotta wrap it up. The other thing, Uranus is actually on its side. So...
Oh, yeah.
The North Pole, quote-unquote, is facing towards the sun, essentially.
Okay.
Right? And it does have a ring system that goes all the way around, similar to Saturn, but it's knocked on its side, so it looks like a circle.
Yeah, and we were talking about this yesterday too, because a lot of people will say that it's rolling, around the solar system, and I remember hearing that since when I was a kid, and I always wondered, how were we able to determine that it was on its side, right? Like, the rings are one thing, but how were we able to determine that it's actually, maybe, the rings are, just some anomaly or something, right? More evidence. I was curious about, the more evidence that would show that it's, on its side. And then we were talking about it yesterday, and it turns out, we're able to see in different wavelengths that the clouds are also moving on the, along the
equator.
Rotation,
yeah.
The axis of rotation, basically, yeah. And there's a couple of theories as to why this is. One of them, and the more popular one, is the fact that,
leading hypothesis.
Yes, okay, there we go. The leading... my brain is fried. The leading hypothesis is that it was knocked over by, an Earth-sized object or moon or something.
Oh, my gosh.
But I was recently reading another hypothesis, and it was saying that Uranus could have had a moon that they were kind of like, I want to say gravitational tugging a little bit was going on. And the moon was in an unstable orbit around the planet, and kind of, as it got pulled away, it just, Uranus kind of just fell over on its side, knocked over, yeah. Pretty interesting hypothesis. I didn't know that there was, I thought it was the whole planet, the moon colliding with Uranus, but yeah, pretty interesting hypothesis. It's always kind of cool to read up on this stuff.
Yeah. And maybe sometime we may definitively know the answer. Because that's kind of how science is, how astronomy is. The more advanced technology that comes out, the latest telescopes, we get more information, more observations, so we can refine our facts, essentially.
Yeah, basically.
Or refine our theories. Because as a species, we went from, this big dome of a sky orbits around the Earth, so we're obviously in the center, to the sun is at the center, to our galaxy contains the whole universe, to...
Our galaxy is one
part
yes.
of the universe. So I love that we're constantly learning, and we're constantly sharing, and we're constantly elevating each other and educating ourselves, which is kind of the main idea behind all the stuff that we do here at the Trottier Observatory.
Yeah, great wrap up, Kyle.
Yeah, thanks. I've been working on that one.
Yeah, that was good.
So,
with that, I think we are thinking about wrapping it up. We are a little bit over time here. We typically end at 8:30, but we just can't stop yapping. We just love space.
We love space. We
Kyle,
love it.
Do you have any closing remarks?
Thank you so much for coming. Thank you to Matthew Simone and Najat, as well as Abby and the director Joanna, who joined us in the chat with moderation. Thank you so much for coming out, all of you. It's been an exciting journey for this virtual Starry Nights, and hopefully we're good to go for next week. I think, hopefully.
In person, yeah.
In person,
Hopefully.
yes.
If
In
it's
person
clear.
this time.
Yes.
Mhm.
Yeah.
So, yes. Thank you so much for coming out. We hope you enjoy your night and your weekend.